Okay, the session is recording. Yeah, so everyone who, start presenting if you have prepared.
So may I present?
Yeah, go ahead.
So is the screen visible?
Yeah, the screen is visible. Yeah, I just had one question. So these computers or laptops, are they given to you by college?
No, sir. They are
Okay,
a personal laptop.
personal. Okay. MIT was supposed to give, right? Any knowledge on that?
No, sir. They didn't tell anything about that.
Okay. Yeah, please continue. Sorry.
Good morning, all. My name is Prathamesh, and our subject is networking essentials and internet governance. And I'm sharing the PPT on the DOCSIS protocol. First of all, with the increasing demands for higher internet speeds, with the people, the cable operators needed to offer blazing speeds or super fast speeds without the replacement of, we can say, millions of spreads of cables, millions of miles of cables and all that. And we have to improve the speeds with the existing wiring only. So to achieve this, we have introduced the DOCSIS protocol, which is a data over cable service interface specification. So it is a telecommunication standard that permits the addition of high bandwidth data transferred to existing systems. So it was developed by Cable Labs and contributing companies like Cisco, Intel, and etc. So, and the current version we are using is the version 4. So why use DOCSIS? With the HFC cables and all that, we can reach up to download speeds of 10 Gbps, which is very faster than the older ones. The DOCSIS, next, the DOCSIS uses active queue management technology, which significantly reduces the latency in, for example, like video gaming and etc. And online games that we always play and all that, all those things. Next is the increased upstream speeds. So upstream speeds, like in YouTube, we are upstreaming the videos and all that. So video streaming and online gaming, we also share our gaming videos and all that in the YouTube and etc. All those things. So we also get good speeds in that too. Then DOCSIS also uses advanced energy management tools, making doing a boost to the energy efficiency. That, this is the DOCSIS architecture, where the cable modem, which we can see here, is the main component on the customer premises. It allows to uh, connect between the different cable companies and access the internet. And in the next side, that is cable company, the CMTS, which is known as Cable Modem Termination Service, is the main device at the cable company side, which allows the what we can say control, which controls the process of upstreaming and downstreaming towards the customer premises. And these are CMTS and the DOCSIS schedule modem share the dual streaming of the IP data flow. So this is the overall DOCSIS architecture. Then why upgrade to 3.1, or we can say 4.0, which is the current version from 3.0. So new physical DOCSIS 3.1, from DOCSIS 3.1, new physical layer technology was introduced, which uses OFDM for downstreaming and OFDMA for upstreaming. Then DOCSIS 3.1 also have better forward error correction, which is uses low density parity check, which is faster than the older versions which are used. Then higher modulation orders. So in that higher modulation orders, means we can use the more have seamless performance, and we can also have the more faster downloading and uploading speeds also. So, and the next point is security also is enhanced in the newer versions of the DOCSIS protocols. These are the versions which are introduced from 1997 till 2017. So the newest version is the DOCSIS 4.0, which is the extension of the 3.1 DOCSIS 3.1. It is a full duplex DOCSIS, and which includes the increased upstream capacity. So we can say that triple or quadruple times the we have increased the capacity in the 4.0 model, and it also supports multi-gigabit speeds, so we can have a large amount of download speeds and upload speeds, and it also doubles the efficiency of the spectrum use. These are the challenges we faced. They might face in the DOCSIS newer DOCSIS versions. So in the higher transmission levels, interference may occur. Then the new requirements for completely new standards means new modems or new devices we require for the newer versions. Then there might be some noise in new frequencies which may affect the other frequencies too. Then we can have signal impairments at higher power, which means at lower power we do not come to know that there might be signal impairments, but at higher power there might be some of them. Then newer frequencies there might be leakages, and which can also affect the transmission of the data. So these are the references from which I have gathered the information. Thank you.
Thank you, Prathamesh. Now, okay. So there are multiple, what do you say, questions in this PPT. So questions in the sense, this is for knowledge purposes. Okay, this is just for your own knowledge. For example, just open up the PPT once, share it.
Yes, sir. Yes, sir. Just a second.
I'll give you an example. Like a domino effect in studying. Okay, this is how research stuff goes on. This is how you learn more and more, get to know deeper and deeper. This is how the scope of a particular study can go very deep, as much as you want. Okay, so for our course purposes, for job and education purposes, it's not of concern. It is not something that will be asked. But like I said, if you are in someone who would go into research, who would do a doctorate, maybe a PhD, maybe something, invent something or some anything, these questions are much important. Okay, just go to the next slide. I'll give you examples of how questions would be uh, covered up. Now, for example, this used by many provide internet access over the existing hybrid fiber coaxial. Now, what is hybrid fiber coaxial, right? So there is this the one that provides the high speeds, or are we using optic fiber? What are we using? Is there something that I can make it better with the speed sharing? How are the versions making a difference? What made the speed go from 100 Mbps to 10 Gbps? Okay, these are the questions that you would ask yourselves and probably do some research. Okay, this is not,
Okay, sir.
again, not for our course purposes, but for education and self knowledge. Next slide. Okay. Yeah, this active queue management technology. Now that's just a word for us. Okay, we don't know what it is. So
Yes, sir.
again, another question would be, what does that mean? How does it work? What is its process? What are the terms used, or the physical? Are there any physical devices that are using, or are they just using virtual concepts, for example? Then again, advanced energy management protocols. What does that mean? What is the definition? What does it use? Okay, do you know there is all this protocol and everything is defined in RFCs? This is a global document which is all over the world, and all these things are made according to that. Okay, for example, I will show you what I mean by RFCs. Go to the next slide. Next. Again, this OFDM, OFDMA. Now I know what frequency division is, but I don't know what orthogonal frequency division, multiple axis is, multiple division multiplexes. Okay, so such questions, I mean, sometimes give you an edge over the others. Okay, so if by chance you go into this field, make sure these things are studied and researched upon. Okay,
Sir,
yeah.
sir, actually, you have given a time of only 15 minutes, so I didn't go much deeper into those
No,
things.
you're not
That's why,
expected to go deeper. That's fine. You're not expected to go deeper anyway. This is good enough. I am saying, if you are someone who goes into research purposes, you do a PhD, or you're gonna invent something, or like self knowledge, then
yes, sir, yes, sir.
this is some of the questions that would go like deeper study. जो हम पूछते हैं ना कि what is air, then what is molecule, what is atom, what is quantum, we go deeper and deeper and deeper into the particular subject, right?
Yes, sir, yes, sir.
So, yeah, so I'm just giving you an example that this is how you would go. So if in future you do this, or in you are absolutely curious and nothing else, okay, no one is going to ask you, you don't have to write an exam. If you're just curious, you can go and check these things. I'm just giving an example of how. Yeah. For our course and concern assignment wise, this is perfect. You don't need to go deeper than this.
Okay, sir.
Yeah, thanks, Prathamesh.
Sir,
Okay, everyone.
so
Yeah.
should I stop
Yeah.
sharing?
So, yeah. Another reason why we are doing this PPT and presentation is so that you guys get better with your presenting skills and explanations and how you speak. Again, right now it doesn't seem much of a difference, or like it's important, but it is very much important. Okay, there is a different, honestly speaking, I mean, apart from this, what's there, course, from experience, I'm saying, your knowledge and your ability to explain your knowledge or put forth your knowledge, cracking the interview, are two different things. So these exercises are important, and I hope you get better at them, so that, well, it helps you in job. Yes, next. Who has prepared? Also, I would like to note that every day maximum 5 to 10 minutes I'll wait. After that, your attendance, you will be marked as not attended, okay? The lecture. 10 minutes I will wait. If you come within that time, you are there for the lecture. Otherwise, you'll be marked absent. Yes, next. Kunal, Digvijay, Shrecha.
Sir, I have to phone. Can I?
Okay, if it is it shareable? I mean, can you do it through phone? I'm not sure.
Sir, I'll try. Can you just tell me if it is visible? Okay.
Okay.
Sir,
Yep,
any
it's
screen is visible and
yeah.
okay. So now,
Yes, go ahead.
so it is a overview of DOCSIS 3 protocol, data link
Mhm.
layer. It is written. Now, introduction to DOCSIS 3. DOCSIS is a basically data over cable service interface specification. It is used for telecommunication standard and used for transmitting data over cable TV system. And
Kunal, you're sharing. Stop.
like telecommunication is done through
It's hung
sorry.
on one particular. Yeah, uh, it's hung on the overview of DOCSIS 3 protocol slide.
Uh, I guess wait a sec.
Kunal, any particular reason why you are not attending from laptop?
Sir, I have tried from laptop, but I'm not able to sign in the application, sir. It's showing error, some type of.
Okay. ठीक है. Make sure you fix it by next time. Okay. It becomes really
Yes.
difficult with the phone. Okay. And if some message comes or something personal information comes, it would get recorded since the session is recording and this would stay on the OneDrive and all. Okay. It's not a big
Okay.
issue right now, but can be a big issue. Okay. So
Okay. Sure.
next
I'll make
time,
sure.
make sure you join by laptop. Yeah, continue. Let's try one more time. If it works, good. Otherwise, you can mail me the PPT.
Okay, sir. Now,
Yeah, good.
DOCSIS 3 is a data over cable service interface specification. It is used for telecommunication standard using for transmitting data over cable system, and it is a transferring data from TV telecommunication through. And next is data link layer overview. It is included in data link layer of OSI model, and data link layer is responsible for node to node data transfer and error detection or correction. Now, key features are channel bonding, IP multicast, IPv6, AES encryption, downstream bonding. Now, channel bonding is a combines multiple channels to increase the bandwidth and improve data throughput. So two channels are combined and the bandwidth is increased and the data flows more efficiently. And
Uh,
IP
just a minute.
yeah.
Anybody knows what this means? What does I mean? Explain this multiple channels to increase bandwidth and improve data throughput. Any idea? Anybody?
Sir, I think it uses multiple bands and so that more data can be transferred through a single band like that.
Okay, a little bit more. Yeah, you're going in the correct direction. A little bit better explanation to that. Okay, so what Prathamesh said was correct. So for example, let's say our FM radio is 98.3, right? So that's the frequency on which the data travels. So what this will do is another channel, suppose let's say 94.3, something like that. So imagine your physics, the waves of frequencies that you see. So what channel bonding is means, like, it's just combining 2 or 3 more of the range of that frequencies, like 2 to 3, making it into one and increasing the bandwidth. Okay, bandwidth is nothing but a door. So let's say it is taking one more door, combining it together, and now it's a big door. Okay, so it takes let's say frequency, pehle frequency was 10 to 15, now it took 15 to 20. So now the frequency is 10 to 20. Okay, which is 10, suppose for example 10 megahertz to 20 megahertz. So anything that you put in that frequency will get transferred. So that's how it combines multiple channels to increase the bandwidth. Okay, so the bandwidth increased from 5 megahertz to 10 megahertz. Is everyone clear?
Yes, sir.
Okay, continue.
Yes, sir.
So now IP multicast. So it supports IP multicast and standard mechanism for configuring quality of service for IP multicast session. So multiple IPs can be supported by this DOCSIS 3, and it supports IPv6, and it supports also advanced encryption standards, and downstream bonding adds additional downstream quadrant amplitude modulation channels to standard broadband DOCSIS system to enable high-speed broadband access. Now, security mechanism implements encryption and secure key exchange protocol to protect integrity and privacy. Encryption
Have you
and
changed the
security.
slide?
Yes, sir.
It still shows me features slide.
Now, security mechanism.
No, not yet. Share again and go to security slide.
Yes, sir. Okay, now it is visible, sir.
No, not yet.
I'll just share it. Okay. Now.
But it's not moving, like it's between the PPTs. Anyway, do one thing. How many slides are remaining after this on the current slide?
Security mechanism conclusion. That's it. Two sides.
Okay, you can just read it out.
Okay, sir. So security mechanism just implements encryption and secure protocols to protect data, and privacy can be maintained. And the conclusion is efficiency and speed of cable internet services are generally increased by DOCSIS 3, which makes it an acknowledged transmission. Thank you.
Okay, thank you, Kunal. Yeah, so 2 more. Shreja. Ashay, have you prepared or you have not? Since this is your first lecture.
Yes, sir, I have prepared, but since it is my first class, so I have kept the PPT simple as I don't know much about
Okay.
this.
So Ashay, you do one thing. You either attach it to this. See, after I close this session, there will be a chat form. You either post it in the chat or send me on the email. I will post the email IDs uh, after the session.
Okay,
Also,
okay.
guys, everyone just in chat post your email IDs, please. Mm, you can do that anytime. Okay. But do it today itself. Uh, Next, I think Shrecha, you're the only one. Please proceed. Shrecha, are you there?
Yes, sir.
Yeah. Please go ahead with the PPT.
Yeah.
Okay. One more thing to note, these PPTs, please do not, I mean, you have prepared, you have presented, and please do not delete it. Please keep it throughout the semester. The reason being, these are in portion. Okay. So questions might be asked to you in exam. Okay. Assignments are in scope of our syllabus and everything. Okay. So please make sure that you do not discard these PPTs. Keep it with yourselves. And I mean, it's a part of study, right? It's an assignment. So there might be questions based on it. Just a point to note. Kunal, could you stop sharing? I mean, your screen is still visible.
Sir, I already stopped. I'll just leave and join again.
Yeah, that would be better. Shrecha, please start.
Sir, just give me 2 minutes, please.
Okay, sure. Why is Kunal not getting admitted? If anybody is in contact with Kunal personally or anything, just message him that I am trying to admit him, but it's not getting admitted. I guess there is some problem with the phone connectivity. I mean, this happens, and that's the reason I said, "Ki, please join with laptop." Sometimes it happens. I am not sure of the reason, and he's not getting admitted. So just if anyone can let him know, please do so.
Sir is visible.
Yeah, go ahead.
Good morning, all. Our topic is to understanding DOCSIS 3.0 protocol and the data link layer. I, Shricha, and my team members are Kuber Gadevar and Digvijay Shinde. So let's start with the introduction to DOCSIS 3.0. DOCSIS, DOCSIS, known as a data over cable service interface specification, is a globally recognized telecommunication standard for transmitting data over cable television system. First, it was released in 1997. It was developed by a Cable Labs. So, what is DOCSIS 3.0? As a part of response to the challenges of maximizing speed, the DOCSIS 3.0 was introduced in August 2006, which is significantly increases data rates, and it also introduced supports for IPv6, IP multicast, and AES encryptions. Its purpose is to enable high bandwidth data transfer via existing coaxial systems that were originally used in transmission of cable television program signals. Um, Next. The key features of DOCSIS 3.0. First is with channel bonding. Channel bonding enables multiple channels to be used together at the same time by a single user or a subscriber. It also provides a higher speed and better performance compared to the earlier DOCSIS version. Then second one is it enhances security, which improves security through better encryption and authentications mechanisms such as AES encryption technique, which protects data and reduce vulnerability. Then third one is a quality of services. It manages and prioritizes traffic to ensure optimal performance for different types of services such as VoIP and streaming. Then next slide will be explained by Digvijay.
Good morning, sir. Is my voice audible, sir?
Yeah. Good morning. Actually, a lot.
Okay.
Yeah.
Sir, there are several functions of this DOCSIS 3.0. First one is error detection and correction. Generally, it manages the error corrections and detection of to ensure the reliable data transmissions. Then the next one is data framing. It generally encapsulates the data into the frames for the transmission over the networks. Then the third one is the flow control, which generally manages the data of transmissions to avoid the congestions and ensure efficiency use of networks. Shiricha, next slide. And here are the two components of the DOCSIS 3.0, that is MAC and DOCSIS MAC protocol, in which first MAC means media access control layer, which generally handles the coordination of the access to shared cable medium, managing how devices shares the network channels. And the next is DOCSIS MAC protocol, in which it defines the specific mechanism for managing the access to the cable networks, including the managing upstreams and the downstreams and the traffics and the coordinations with the CMTSs. Next, Richa. So that's all. Thank you, sir.
Okay, thank you. Okay, like I said, the purpose of these assignments is for personal knowledge, your ability to present something, okay, and this will be asked in might be asked in exams because this comes under the scope of syllabus. Okay, so there are multiple what do you say interfaces or aspects to an assignment, so please do them. These are very helpful for your knowledge, understanding of a particular topic. And another point to note is that these not all assignments are marked, but the catch is you don't know which assignments will be marked, so each assignment is expected to be done. For example, if I give you 4 5 assignments, you don't know which ones are going to be marked. Okay, there will be marks for some of the assignments. Okay, I hope that is understood. So I make sure that all the assignments are done. All the assignments are kept. Please do not discard them. Please keep it through the entire semester. Okay, right. So 1, 2, 3, 4 assignments. Ashay, I am expecting yours later on through mail or something like that, but I will mark that you have provided your assignment. Okay.
Sir, I have actually done the assignment, but it is not that much uh, appropriate. So should
That's
I?
fine. No,
So
that's fine. Just yeah, you can take one more week if you want, since you joined today. It's your first lecture. That is fine. You, now that you have given me your email ID, I will add you to that access to the recording. Please do go through the recording. Okay.
okay, sir.
Ashay, wait, let me check. So I have Digvijay, I have Ashay, Prathamesh, Kunal. One more remaining. Shrecha, your email ID is remaining. Please put it in chat. 1, 2, 3, 4, 5, 6. 1,
Sir,
2,
excuse me,
3,
sir.
4. Yeah.
Sir, Kuber is just traveling from hometown to Pune, so he is not available to join the lectures.
Okay. Digvijay, I think Prathamesh. There is one more. Kunal. Digvijay, Shrecha. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Who's is missing? Shrecha is there. Digvijay is there. Asha is there. Prathamesh is there. Kunal. 1, 2, 3, 4, 5, 6. What am I missing? 1, 2, 3, 4. Oh, Shrecha is twice. Okay, fine. Yeah, thank you for your IDs. Kuber is traveling. Okay, then make sure to tell Kuber to give his assignment on mail, and then next time he will present it. Okay.
Okay,
Until
sir,
then,
sure.
I will not mark it as assignment submitted.
Okay, sir.
Okay. Ashay, okay. So just for Ashay, I'll just one sentence recap. So last lecture we went through OSI model. Okay. So there is physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. This is the order I told was bottom to top. Okay. And out of which physical layer is for the cables, data link layer is what kind of protocols will be applied on the data and the data that is being sent on the physical cables. Network layer is to find stuff on the internet. Okay, it uses IP address, IP protocols. Then there's transport layer, which is just responsible for making sessions and making sure that the data is transferred from one point to another. Then the session layer is technically to maintain those sessions established by the transport layer. Presentation is for the particular usable format. Okay. So there was different systems And if in order to get everything on one system or one common platform, presentation layer was used. And then there is application layer, which is so that we can transfer a usable format from one device to another. Okay, it is more of breaking data into chunks. In that is what happens in application layer. In more detail, I expect you to go through the recording. I will add you to that, and you will probably get a mail on Gmail with the link for the recording. Okay.
Okay,
Let's
sir.
start with the next part. Yeah. Also, a small note. So the subject, I know it is network essentials and internet governance. I will change that soon. But it is actually networking and internet foundations. Okay, they changed it. I don't know why, but portion somewhat remains same. Actually, a little bit more is added. But yeah, a point to note that the subject is networking and internet foundations. I'll make the changes to the teams. Don't worry. Okay. Thanks. Right. So thank you for your presentations. Let me know once my screen is visible. Visible, good enough?
Yes, sir.
Yes.
Okay. Right. Okay. So next is we also saw layered architecture. Layered architecture is nothing but the same thing, the OSI model layers. Okay, we also saw encapsulation. Encapsulation is nothing but the addition of headers to each of those packages, and at every layer what kind of header gets attached. You know, it goes from segment to packet to frame. Okay. Yeah. So the next is peer-to-peer processes. So what does peer-to-peer process means? Peer, like one point to another, one peer to another peer. Peer is nothing but one device, and the other peer is the other, like one device to another. Okay. So refers to interactions where two or more devices communicate directly with each other without relying on a central server. In the context of computer networks, P2P processes involve sharing resources like files, data, or processing power among networked computers. Each peer acts both as a client requesting resource and a server providing resources simultaneously. Just give me a minute. I'll connect the pad. Okay. Right. So what is our general architecture? General architecture is, this is your PC. Okay. And there is a server. What is the server? Server is suppose Facebook. Okay. So when you go to Facebook, www.facebook.com, what does it give you? It gives you a login page, right? Your profile picture is your username, and this is your. So this is what client server architecture. This, your PC is the client, and this is the server. In peer-to-peer, there is nothing as server. Okay, you both are, so there is a PC and there might be another PC here as well. Okay, here there is a PC and there is a server. Here it is PC. It can also be server to server. Okay, it can also be server to server. It's just devices. Doesn't matter what kind of device, but PC to PC, server to server connection is P2P. Now, why this is? Because in this, when you typed www.facebook.com, you are sending a message to the server. Okay, you are requesting something from the server. In this method, the server does not request anything from you. Okay, the server does not request anything from you. But in PC, this P2P connection, P2P process, it can. Okay, so you are asking something from this device, the other device can ask something from you as well. So it is a two-way connection. It is not a one-way connection. इसमें कैसे होता है कि everything is asked by you from the server. Here things can be asked from you as well. Okay. So each peer acts both as a client and a server, right? Someone who's requesting resources and someone who's providing resources, both. So your laptop is asking something and is also giving something, depends on what type of process or connection you're on. So these are called P2P processes. Now, P2P networks are commonly used in file sharing systems, decentralized applications, and distributed computing. Popular examples of P2P applications include BitTorrent for file sharing and blockchain networks like Bitcoin, where each peer maintains a copy of the ledger and participates in the consensus process. For example, distributed computing matlab kya? You both have an application. Suppose you both have a database. Okay, here and here. Something comes, let's say there are 100 entries. So distributed computing mein kya hota hai? You do one entry, this does one entry, this PC does one entry, and this PC does another entry. So in 1 second, there are 2 entries that are going. Okay, so instead of going it one by one, like पहले मैं PC1 का खत्म करता हूँ and then मैं PC2 पे जाऊंगा, or whatever method, one by one method के अलावा, this is distributed. Okay, the load is distributed between 2 computers. So in 1 second, there are 2 entries. So previously it was 100 seconds, 100 entries. Okay, now it is just 50 seconds, 100 entries. Okay, so this is an example of distributed computing. Another of Bitcoin. Each of you has a ledger. That means ledger is nothing but a book that is used for maintaining transactions. So let's say A transfers B some, let's say he transfers 1 Ethereum. Okay, so what, A has a book, B has a book. Okay, he says that I gave B 1 Ethereum on 31st August 2024 at 10:28 a.m. Then B says I received A from A1 Ethereum at so and so A. Then both of them say okay, like they sign and they say okay. They verify the transaction and then it is authorized, and that 1 Ethereum gets transferred properly. Okay, so B receives the money from A. That is what this blockchain ledger part works. Okay, so there is consensus. There is no request as such going on. There is just transfer of information. Like he is saying that, hey, I transferred you this, please sign. He is saying, yes, I got it, please acknowledge, please sign. So there is a message transfer between the two. It's not like A is saying ki, hey, give me your transaction log, give me the sheet, and I will sign it and give it back to you. No, that's just one way messaging. That's just one way request which happened over here in client server architecture. In this, A is saying ki, give me your sheet, I will sign and give it back to you. And B is also saying that, hey, give me your sheet, I will sign and give it back to you, so that our transactions are verified and the money is transferred. Okay. Now, let's go into the BitTorrent example a little deeper. So BitTorrent is a peer-to-peer protocol primarily used for distributing large amounts of data over the internet efficiently. Unlike traditional client-server models where a single server provides data to multiple clients, BitTorrents allow users to both download and upload parts of files simultaneously from each other. Like I said, what is traditional client-server models? This. You are the client, you ask the server, the web server, to provide you Facebook. What he does, he gives you the login page and then the feed page and everything else. In P2P processes, there's nothing like that. There is no dedicated server. You might get the Facebook page from your friend instead of getting it from a server. Okay, so what are its somewhat components? First is file splitting. Okay, so when you download a file using BitTorrent, the file is divided into small pieces called chunks, and each chunk can be downloaded independently from different peers in the network. So like this is, let's say this is the internet. Okay, and you are on let's say BitTorrent site, and there are multiple people, right? There is you, then there is one more person, there is USA, there is Europe, there is Russia. All these people are there. Okay, and they are interconnected. Okay, and then there is a file that you ask. Now let's say that the file is over here. Okay, but what BitTorrent does is for P2P processing, there are multiple files. So there is a 1 GB movie, and it is split into multiple things. Let's say it is split into 5 parts. 1, 2, 3, 4, 5. So each becomes 200 MB, right? So one file may be here, another may be here, and then here. So what it does is it's divided into small pieces called chunks, and each chunk can be downloaded independently from different peers. So I can download one chunk from here, one from here, one from here. Okay, anything. This is you. So you can download any of the chunks from anyone. Okay, if it was a client, it was a server, you would have to download everything from here. But since it is not, you can download it from other people. Like these are other people and you are downloading it from them. Then the concept comes of swarming. Okay, so instead of downloading the entire file from a single source, your BitTorrent connects to multiple peers who already have parts of the file, what I explained here. It downloads different chunks from different peers at the same time. Meanwhile, your client also uploads the chunks you have already downloaded to other peers who need them. So let's say, so simultaneously, first part इससे download कर रहे हो, second part you're downloading from here, and third you're here. So simultaneously, you're downloading 600 MB of your movie from your parts. It gets to your PC, and now your PC becomes a source for others, for these other people. Okay, for these other people to download the files. Now these people over here that I showed. Okay. Okay, let's say these over here. Now they will start downloading it from you because you have already these files, top 3. Okay, so you become so where was I? Yeah, so you become the source of these 3 files for these people. Okay, that's how swarming works. Then seeding and leeching. Okay, next part. So what is a seeding is once you have downloaded the entire file, you are a seeder. Now you become the one who's going to provide the files, and a leecher is someone who is still in process of downloading. So before you were a leecher because you are still downloading 1, 2, 3, and 4, 5 are still remaining, while you become a seeder for the rest because you have 1, 2, 3 files. Okay, so 1, 2, 3 parts are there. So someone, let's say this guy over here. Okay, this guy over here decides that he wants the files. Okay, he starts downloading. Now he'll start downloading from the first part. You already have the first part because you downloaded. So now you are giving him the file. Okay, so previously now, and you are now downloading the fourth part. You on one hand are downloading the fourth part. Okay, you are a leecher and you are also a seeder because you are giving the first part to this person over here, to this PC over here. Okay, so that's how these things work simultaneously. That's how P2P processes are person to person processes you can consider. Okay, peer is nothing but a device. So one device to another device transfer. The devices can be anything. It can be two laptops, two phones, two servers, or to PCs, anything. Then a tracker. Okay, there is something called as tracker. So a tracker is a server that keeps a track of all peers in the network. तो एक यहाँ पे, ठीक है, यहाँ पे एक server होगा who will be a tracker. Now what this does, it keeps track of all peers. कितने peers है? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 peers. In 8 peers का वो track रखता है who are sharing the same file. Sharing is going on of the same file. So it helps your BitTorrent client connect to other peers, making it possible to download and upload pieces of the file efficiently. ठीक है, तो ये ट्रैकर ट्रैक रखता है कि 8 peers हैं, उसमें से ये हम जो है, हम our peer number is 3. It has downloaded 3 files and it is downloading 4th file. At the same time, it is giving the first part to peer number 7, let's say. ठीक है, so ये सब tracking happens on this server which is on BitSite, but it which is on BitTorrent, but it is thoda background mein, not something that will be visible to you. Okay, so some BitTorrent systems also use something called as distributed hash table to locate peers without relying on centralized tracker. ठीक है, नेक्स्ट एफिशिएंसी तो तुम्हें समझ ही गई होगी कि simultaneously डाउनलोड भी हो रहा है, अपलोड भी हो रहा है. So there are 2 people within 1 minute are getting the data that they need. ठीक है, very simple. Like this example of entries. पहले it was 100 seconds 100 entries, now it was 50 seconds 100 entries. Same thing. So in a small period of time, okay, a huge amount of data is being transferred. Another efficiency is that there is no load on a single device. ठीक है, इसमें अगर सर्वर होता, जैसे कि मैंने कहा फेसबुक यूट्यूब वाला एग्जांपल, there is a laptop and it is asking stuff from a server, let's say YouTube server. So the problem is that every request is coming to this server. ठीक है, so like there are India 1 crore लोग हैं, so 1 crore requests are coming to this server for every minute, let's say. But in this case, this file sharing case, you are getting 1 request, this PC is getting 1 request, this is getting 1, this is getting 1. Okay, so instead of 1 person, like suppose instead of you, okay, instead of you getting 8 requests, give me the files, give me the movie, you getting only how much? 1 request from this person, right? You're getting 1 request from this person. This PC over here, number 1, is getting 1 request from you. This is getting 1 request from you. So each of the PCs in the network are getting only 1 request. Nothing is being overloaded. None of these PCs are getting more than 1 request. Like it's okay if you get 2 or 3, that's fine. But the point is that nothing is being overloaded. ठीक है, इस केस में कैसे था? In this case, everything was going to one place, but here different things are going to different places. Okay, that's the efficiency. To put it in words, it is efficient because distributes the load across all users in the network. Large files can be shared quickly, and the original uploader doesn't have to bear the entire burden of distributing the files. Like I said, entire file is of 1 GB. None of the device has to bear the burden of distributing 1 GB of data. They all can distribute 200 GB of data, which is a reduced A. So the burden is distributed in the network. So this reduces the impact of original uploader. Whoever uploaded the 1 GB file, उस पे जो load था वो कम होता है. Okay, so this reduces the impact on original uploader's bandwidth, making it more scalable solution for large files. Okay, understood?
Yes, sir.
Yes, sir.
Yes. Shubham, any reason you're late?
Sir, light meeting, please charging later.
Okay, I didn't get that, but that's fine. The point, I will give an exception this time, but a point to note is that I will wait for 5-10 minutes. Okay. After that, if you join, you will
Okay,
be
sir.
marked absent. Okay, it's your choice. You want to attend after that. I mean, for example, after 9:40, it's personally your choice if you want to attend the lecture or not. Okay, but you will be marked absent if you join after 9:40. Today, I'll give you an exception. Okay. Next. Introduction to network layer. Okay. What we'll do is let's take a 10-minute break. Okay. And then we'll get back. I mean, let's get back with a little bit fresh mind. See you at 10:52. Okay. Is everyone there? Everyone back?
Yes, sir.
Yes, sir.
Okay.
Yes,
Good.
sir.
Thank you. My screen is still visible, right? I mean, it's still sharing.
Yes,
Yes,
sir.
sir.
Okay. So yeah, next, introduction to network layer. Okay. So layer 3 in the OSI model is called network layer. Network layer manages options pertaining to host and network addressing, managing subnetworks and internetworking. Okay. When someone asks you in exam, what is network layer, what to write, you write this. Network layer takes the responsibility for routing packets from source to destination within or outside a subnet. If an explanation is asked, you tell them this. Okay, what is its purpose? Routing packets from source to destination within or outside a subnet. Now I understand that you might not know what a subnet is. We will go through it later on. Okay, but just for now, you can consider it a network. So within or outside a network. Now, what is a network? Basically, your home is a network. Okay, your phone, your PC, laptop, whatever you have, if you have a pad or anything, all this forms a network. Your router, modem, and everything is one network. So suppose in a building, so your building is one network, then the building besides you is another network. So sending messages within your house, like your PC, you are sending a message to your father, mother, or you are sending it to your friend who resides in another building. So that's what network layer does. Okay, responsible for sending messages from source to destination within or outside a subnet. Sorry, a network. Now, okay, two different subnets may have different addressing schemes or non-compatible addressing types. Same with protocols. Two different subnets may be operating on different protocols which are not compatible with each other. Network layer has the responsibility to route the packets from source to destination, mapping different addressing schemes or protocols. Let me quickly show you what that is. Okay. What I mean by subnet is, okay, this is a network and these are subnets. Okay, sub networks are subnets. So this is network and these are sub networks, which is subnets. So this is subnet 1, subnet 2, subnet 3, subnet 4. Okay, plain and simple. Okay, another way of imagining, this is a building. Okay, this building is called network and each floor is a subnet. Okay, so this is subnet 1, subnet 2, subnet 3, subnet 4, subnet 5. Okay, so two different subnets may have different addressing schemes or non-compatible addressing types. Okay, now the address of this is floor 1, this is floor 2, this is floor 3, फ्लोर 4, फ्लोर 5. ठीक है, इनके addressing schemes अलग है, numbers अलग है. So same protocols, two different subnets may be operating on different protocols which are not compatible with each other. Network layer has the responsibility to route the packets from source to destination, mapping different address schemes and protocols. So it is the responsibility of network layer to make sure कि first floor से fourth floor तक message जा रहा है. Okay, in spite of different addressing, different protocols and everything. Okay, different addressing and different protocols. जो कुछ भी अलग हो, it's not of our concern. ये responsibility है network layer की to make sure कि message यहाँ से यहाँ जाए from first floor to fourth floor. Okay, next. Layer 3 functionalities. Devices which work on network layer mainly focusing on routing. Routing may include various tasks aimed to achieve a single goal. This can be addressing devices and networks, populating routing tables or static routes, queuing incoming and ongoing data, and then forwarding them to quality of service constraints set for those packets, internet working between two different subnets, delivering packets to destination with best efforts, provides connection oriented and connectionless mechanism. All these will okay. Yeah. We'll see all this from time to time. Okay. Somewhat in parts we'll learn about this, but this is more of like academic purposes, right? So if someone asks you to give the functionalities of network layer, okay, this might be a question in the exam, you give them this answer. Okay. Network layer features. So what are those? It's quality of service management, load balancing and link management, security, interrelation of different protocols and subnets with different schema, different logical network design over the physical network design. L3 VPN and tunnels can be used to provide end-to-end dedicated connectivity. Again, VPL will learn what these quality of service, load balancing, I'll tell you, and all this. We'll get through it part by part. This is for what to say, assignment, interview, and exam purposes. Okay? These are the features of network layer. So what are the so questions can be like, what are the functionalities of network layer and what are the features of network layer? Okay. Next. So that was a brief introduction of network layer. Okay. Network layer is what? Key transferring of messages from point A to point B. Point A has IP address, point B has IP address. Okay, network layer's responsibility is to send messages from here to there. Imagine this example. There is a building called network. Each floor is called a subnet because it is a sub network. Okay, and there are different addressing and protocols that they have. Okay, like this has F5, F4, F3, F2. And it is the responsibility of network layer to send messages from one floor to another. In this case, from first floor to fourth floor, subnet 1 to subnet 4. Okay, and during this, these are the functionalities that it can perform by using these features. Okay, next, IPv4 addresses. Okay, anybody who has studied IPv4 addresses or just know them by the name and a couple of here and there information?
Yes, sir.
Okay, yes, for like you have studied or just know a little bit of information?
Sir, studied.
Okay, good. Okay, for the rest, the IP address is a unique identifier for your device on the public internet. Okay, so like that day I showed you, these are devices, okay, on the internet. Okay, this can be a PC, laptop, smartphone, smart TV, then a server and another tablet, for example. Okay, all these devices are on the internet. Now, how do you identify people? By their names. My name is Yashraj, there's Prathamesh, there's Digvijay. That is how you identify a particular person. You add in a surname. Now it becomes more specific and more easily you can identify them. Other ways to identify, now there can be many Digvijays, for example. Okay, you add a surname, now it goes from 100 to 50. There are only 50 Digvijays with surname S1. Okay, you add it Pune, and it goes to 25. There are 25 Digvijay's S1 in Pune, and the ones who are of a particular age, okay, let's say 22, who are from so and so city and currently studying in so and so college. And that's how you narrow it down to one person, right? The one who is attending here right now. Similarly, IP addresses are unique identifiers. For what? For devices on the internet. What devices? Anything. PC, laptop, TV, the smart TV, not the old dabbawala TVs. Smartphones, smart TVs, tablets, your smart watches, so etc, etc, etc. All these. Now they want to identify others, right? They want to notify, like talk to others, like how I'm talking to Digvijay, because I know who he is. I know his name, I know his surname, I know he is studying this, that, and I know this is the person I'm talking. Okay, so how do the devices know? They know it by IP address on the internet. This is 1 PC, 2, 3, 4, 5, 6, 7. Okay, these all are PCs. Now let's say this PC A wants to talk to PC B. How will he know? First of all, he needs to identify where on the internet it is. This is entire internet. There are more devices here. How does he know that it is located here in this section? Okay, first he has to identify in which section he is, and then in this section there may be many more. There may be 1, 2, 3, 4. So from this 4 devices, how does it know that it is B? Based on the IP address. Okay, so A, for example, has an IP address of 1.2.3.4. Okay, and it has to send a message to B, which is 5.6.7. Somebody is not on mute. Shreya. Okay, 0.8. So now A identifies B by its name, which is 5.6.7.8, and it is ready to send a message. Okay, that's how it knows this, like that's how it identifies B, and it tries to send him a message. Now there is one problem, like I said, which is location of it in B, location of B on the internet. Okay, now that's where subnets come in. But before, okay, that's where subnets come in. So the entire is, for example, this is the, okay, this is the internet. Okay, the internet is divided into sections. Okay, what are these sections? These are subnets. Okay, or you can say, assume, let's assume instead of internet, let's assume this to be network. Okay, this is a network. Okay, what is this network? This network is of, let's say, a company. This is a network of a company, and this company has subnets. Why does it have subnets? Because of departments like HR department, production department, then finance department, law, okay, then testing, then quality control, okay, quality control, then X and Y. Okay, these are different subnetworks. Okay, subnets. Now HR wants to send a message to B, to a PC in law department. Okay, This is A, this is B. Now A has an address of 123.4. It wants to send a message to B. It knows the name of B, which is 5.6.7.8, but it doesn't know where in this entire network this B is. For him, for A, he doesn't know this part, this section, this B. This law department, it doesn't know. But how will it know? Then because something called as network portion of the IP. Okay, so an IPv4 address consists of two parts. Okay, two parts. One part is network portion and the other is host portion. Okay, network portion is what? To tell you कि कहाँ पे है. Okay, where is it in 1, is it in 2, is it in 3, is it in 4, or is it in 5? And host is the specific device in that for host. ठीक है, so इसमें, right, like your house, for example. So your house address has two parts. Your house address has two parts. Pune, comma, A apartment. Okay, my address has two parts. Mumbai, B apartments. Okay, now the network part is this, Pune, Mumbai. Where in the network? ठीक है, महाराष्ट्र एक नेटवर्क है, उसके सबनेट्स है पुणे, मुंबई, ठाणे, नागपुर, नासिक एक्सेट्रा. ठीक है, ये उसके सबनेट्स है. ठीक है, तो ये नेटवर्क जो है, नेटवर्क पोर्शन, ये मेरा एड्रेस है पुणे ए अपार्टमेंट, ये दूसरा एड्रेस है मुंबई बी अपार्टमेंट. उसमें से ये जो सिटी जो है, दिस बिकम्स माय नेटवर्क पोर्शन, कि कहां इस पूरे महाराष्ट्र में कहां से कहां मैसेज भेजना है, इज आइडेंटिफाइड बाय द नेटवर्क पोर्शन. ठीक है, और कौन सी बिल्डिंग में भेजना है, इट इज आइडेंटिफाइड बाय द होस्ट पोर्शन, which in this case is A apartment. ठीक है, so from the location Pune, okay, which is the network part of IP, ठीक है, और उसका जो होस्ट है, मतलब मेरा जो पीसी है, फॉर एग्जांपल A apartment, which is the host, to Mumbai, which is the network portion of my destination IP. एंड उस मुंबई में भी तो कहीं पे भेजना होगा ना. मुंबई कितनी बड़ी है, तो मुंबई में बी नाम के अपार्टमेंट में मुझे भेजना है स्पेसिफिकली, विच इज द होस्ट. ठीक है, समझा?
Yes,
with
sir.
an example, yeah, with an example, this is the IP. So A is 203.0.113.0 wants to send a message to B, which is 133.1.0.10. Okay, A wants to send a message to B. Now here, this is the network portion, this is the host portion. Similarly, for B, this is the network portion, this is the host portion. तो दिखने में कैसा लगेगा? ये मेरा नेटवर्क है, ओके, और इंटरनेट है, नेटवर्क और इंटरनेट. ए उस इंटरनेट नेटवर्क के इस कोने में है, बी इस कोने में. जब ए को मैसेज भेजना होगा, तब उसे कैसे पता कि ये वाला कोना है? उसे पता होगा बिकॉज ऑफ दिस पार्ट 0. ये जो नेटवर्क पोर्शन है, उसकी वजह से उसको पता है कि मुझे यहां से यहां भेजना है. ठीक है, ये बीच वाला जो भी सेक्शन है, इट इज नन ऑफ माय कंसर्न. मेरा नेटवर्क क्या है? 13310. अब इस सेक्शन में, ये इस सेक्शन में देयर आर मल्टीपल पीसीस. उसमें से कौन सा पीसी? उसमें से पीसी नंबर 10, ये जो लास्ट का पोर्शन है, तो .10. तो ये जो लास्ट का .10 है वो ये है, तो ये होगा .11, .12, .13, .10 और .5. तो कौन सा पीसी? ये वाला पीसी. ठीक है. सेम फॉर ए. सो दिस इज माय नेटवर्क. ये सेक्शन ए, सेक्शन बी. इस सेक्शन में भी कई सारे पीसीज हैं. ठीक है. इसका एड्रेस है 203.0.113. उसमें से ये जो पीसी है .0, वो सेंडिंग अ मैसेज टू 133.1.0, जो कि ये सेक्शन का एड्रेस है. और इस सेक्शन में ये जो पीसी है उसका है .10 to 8. ठीक है. फ्रॉम दिस पीसी through the internet to this B. Getting it? This is very important. अभी भी डाउट है तो अभी पूछो. We are not going ahead unless you 100% know this. Guys, yes, no?
Sir, no doubts.
Okay, Prathamesh is good. Others?
No, sir.
Okay. Subnetting, VPN, or the virtual IPs, all this is based on this. So please tell me now. Ashay, Shrecha, Kunal.
No, sir. No doubt.
No, sir.
Okay.
No doubt.
Shrecha? You can type if there is some problem with the mic. Okay. Yeah, but now the question is how to identify the network. So IP address कैसे होता है? It is of 8 bits. The structure of an IPv4 address is 8 bits dot 8 bits dot 8 bits dot 8 bits. Okay. Now, how do I know इसमें से कितना पार्ट नेटवर्क का पार्ट है और कितना पार्ट होस्ट पार्ट है? राइट. द एग्जांपल्स दैट आई गेव यू वर वेरी सिंपल, कि मैंने पहले 3 ये लिया. सो मैंने क्या किया, ये 3 पार्ट्स नेटवर्क पोर्शन हुआ और ये लास्ट पार्ट होस्ट पोर्शन. बट दिस इज नॉट द केस एवरी टाइम. ओके. I can keep this as network portion, okay, and this entire thing as host portion. ठीक है. I can keep anything. I can keep these two as network, these two as host. Okay. So how do I decide? Okay, or how do I identify? How do I identify what is the network portion and host portion? How do I identify the network portion and host portion from a given IP address? Okay, so if I give you these IP addresses, can you tell me इसमें से नेटवर्क पोर्शन कौन सा है और होस्ट पोर्शन कौन सा है? राइट. कौन सा वाला सिटी नेम, कौन सा वाला सिटी एड्रेस है और कौन सा वाला उस पर्टिकुलर बिल्डिंग का एड्रेस है? जस्ट बाय लुकिंग एट इट, कैन यू टेल मी?
No, sir.
सर 3 वाला सिटी एड्रेस है और
कौन सा वाला?
113
ये 113, ये वाला.
लास्ट वाला, सेकंड वाला.
अच्छा, नो दैट्स नॉट पॉसिबल। सिर्फ देख के यू कैन नॉट टेल। वो तो मैंने जस्ट बिकॉज मैंने मार्क किया इसका मतलब ये नहीं कि वो होस्ट पोर्शन है और ये है। सो यू कैन नॉट, मतलब जस्ट किसी ने कुछ एड्रेस दिया रैंडमली, उससे यू कैन नॉट आइडेंटिफाई what is the network portion or host portion. Okay, so there are two ways of identifying that. Okay, one is classful addressing and the second is classless addressing. Okay, classful addressing was used 1995 and before. Okay, we use classless now, which is 1995 and later up to present. These are the two ways, two methods to identify network portion कितना है and host portion कितना है। ठीक है, and okay, classless में the thing is कि the classes are already defined. Classless में we use something called as subnet mask. Okay, in classless addressing there is something called as subnet mask which we use to identify the network portion and the host portion. Okay, how कैसे ये हम कल देखेंगे। ठीक है, समझा? नेटवर्क और होस्ट पोर्शन आइडेंटिफाई करने के दो तरीके हैं, एक है क्लासफुल, एक है क्लासलेस। क्लासफुल में क्लासेस ऑलरेडी डिफाइंड होती हैं, उससे हम आइडेंटिफाई करते हैं, विल सी दैट। और क्लासलेस में देयर इज समथिंग कॉल्ड एज सबनेट मास्क, जो हम यूज करके आइडेंटिफाई करते हैं कि नेटवर्क पोर्शन कौन सा है और होस्ट पोर्शन कौन सा है। इज दिस क्लियर?
Yes, sir.
Yes,
Okay,
sir.
then thank you so much. That's it for today, guys.
Thank you, sir.
Thank you.
Thank you, everyone.